In this video, we will practice solving trigonometric equations, and many of them will involve double angle identities. So we will be referring back to the double angle identity sheet and using these formulas. Now, along the way, we will also be assuming that you have memorized these facts. So if you have not memorized these facts, pause the video and memorize them now. All right, looking at problem number 1. Whatever you do, never divide by a trig function, but instead you can subtract. So subtracting cosine squared from both sides, that will give me cosine 2x minus cosine squared x is equal to 0. Now I see I've got my cosine 2x right here, and looking at my identities, for cosine we have 3 different versions of the double angle formula, but looking at the rest of the equation, since we have cosine, I'm going to pick the version that involves cosine. So 2 cosine squared minus 1. Okay, so this will be 2 cosine squared minus 1. And then I'll just bring down my minus cosine squared is equal to 0. These are like terms. I've got my 2 cosine squared minus cosine squared. If I put those together, that just gives me cosine squared. So I've got cosine squared minus 1 is equal to 0. Adding 1 to both sides, I have cosine squared is equal to 1. Taking the square root of both sides, I have the cosine of x is equal to plus or minus 1. And then I just ask myself, where is cosine equal to positive or negative 1? Picture the quadrantal angles that go like this: 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosine is an x value, so the x values are positive 1 and negative 1 at these 2 angles. So x is equal to angle 0 or pi. So those are the solutions to problem number 9. All right, taking a look at problem number 10. I am going to add sine 2 theta to both sides. So that will give me 2 sine theta plus sine 2 theta is equal to 0. So I've got this double angle expression, so I'm going to use my double angle identity. Sine of 2 theta will equal 2 sine theta cosine theta. So I'll bring this down, 2 sine theta, but this will become 2 sine theta cosine theta. I see that we have 2 sine theta in both terms, so I'm going to take out that GCF. So if I take my 2 sine theta outside of parentheses, that leaves 1 plus cosine theta. Now I will use my 0 product property and set each factor equal to 0. So sine 2 theta equals 0, and 1 plus cosine theta equals 0. Dividing by 2 on both sides, I have sine theta is equal to 0. Subtracting 1 on both sides, I have cosine theta equals negative 1. All right, so where does sine theta equal 0? Sine is a y value. Okay, maybe I can just use my same drawing from before. Sine is a y value, so the y value is 0 here and here. Okay, so far that gives me, well, I guess I should say theta instead of x. So far that gives me theta is equal to 0 or pi. Now where's cosine equal to negative 1? Cosine is an x value. All right, and here it's negative 1 right there. but that's pi, I already had that. So my solutions are 0 and pi. All right, that's it. So that's the answer to number 10. Number 11. I am going to subtract sine 2 theta from both sides. You know what, maybe I'll do the substitution first. So I have negative 2 cosine theta equals sine 2 theta, according to our identity, is 2 sine theta cosine theta. So this will equal 2 sine theta cosine theta. Now I'm going to subtract this from both sides. So that's going to give me negative 2 cosine theta minus 2 sine theta cosine theta equals 0. Okay, GCF. I see I have negative 2 cosine theta, and I have negative 2, and I have cosine theta. So I can take out a GCF of negative 2 cosine theta. That's going to leave behind 1 plus sine theta. Okay, because negative 2 cosine theta times positive sine theta would give me negative 2 sine theta cosine theta. So 0 product property. Negative 2 cosine theta is equal to 0, and 1 plus sine theta is equal to 0. Dividing both sides by negative 2, I have cosine theta is equal to 0, because 0 divided by negative 2 is still 0. Subtracting 1 from both sides, I have sine theta is equal to negative 1. All right, where is cosine 0? All right, so I have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Cosine is an x value. So where's my x value going to be? 0? Here and here. Okay, so that's theta is equal to pi over 2, all right, and 3 pi over 2. Okay, now where is sine theta equal to negative 1? Well, sine is a y value, so where's the y value negative 1? Right here. Well, that's 3 pi over 2, and we already have that, so we don't get any new solutions here. So these are the only two solutions for problem number 11. So for number 12, let's get 0 on one side. So this is adding cosine 2 theta to both sides. So this will be 2 plus 3 cosine theta plus cosine 2 theta is equal to 0. Now, cosine 2 theta, we can go ahead and use the identity to do the substitution. Well, let's be careful. There's 3 different versions to choose from. The rest of the problem has cosine in it, so I'm going to pick the version that does cosine. So I'm going to replace this with 2 cosine squared minus 1. So here I will have 2 cosine squared theta minus 1. And I'll just bring the rest of this down. All right, I do have these like terms. Just the 2 and the negative 1 are like terms. So I'm going to write these in the proper order, descending exponential order. So I'll put the 2 cosine squared first, followed by the 3 cosine theta second, and then 2 minus 1 is 1. So this is just going to be a factoring problem. So I'm going to go ahead and factor this. 2 cosine squared can only factor as 2 cosine theta times cosine theta. Then I look at the final term. 1 can only factor as 1 times 1. Now, inner plus outer must equal middle. Inner, I have 1 cosine theta. Outer, I have 2 cosine theta. I'm trying to make 3 cosine theta, and that will happen if both of these are positive. That means both of these would be positive. So there we have factored it. So now we will use the zero product property and set these two factors equal to 0 and solve. So solving the left side will give me 2 cosine theta is equal to -1. And dividing by 2, I have cosine theta is equal to -1/2. Subtracting 1 from both sides, I get cosine theta is equal to -1. Now, the cosine of what angle is equal to -1/2? Well, forget the negative for a second. The cosine of what angle is 1/2? Hopefully you've memorized that that is pi over 3. Now, that's the reference angle. That is not the answer. That lets us know that we should be picturing the following diagram. All right, these are pi over 3's. Now, all 4 of these angles have a reference angle of pi over 3. We want the cosine to be negative, though, -1/2, and cosine is negative on the left. So that's why these 2 angles will be my solutions. So I've got theta is equal to 2 pi over 3 and 4 pi over 3. All right, that's what I have so far. Now, where is cosine equal to -1? Well, now we're talking about quadrantal angles. Okay, and at pi, the coordinates are -1, 0, and cosine is this x value. So this is where cosine is equal to -1. So pi. So these are the 3 solutions. All right, so that's it for problem number 12. Okay, let's take a look at problem number 13. I'm going to go ahead and get 0 on one side. Okay, let's see. So if I subtract 2 cosine theta from both sides. All right, well that's convenient because both of those are going to end up canceling out. So now I have negative sine 2 theta plus radical 2 cosine theta is equal to 0. I see this double angle happening. Let's go ahead and use our identity. So sine of 2 theta will equal 2 sine cosine. So I have this negative still, but I will have negative 2 sine theta cosine theta. Okay, that is just this part so far. Now I'm just going to bring down the rest of it. So here comes my plus radical 2 cosine theta. Okay, I see a common factor. I see a GCF happening, cosine theta, cosine theta. So let's bring that out front. So here's my GCF of cosine theta. That will leave behind negative 2 sine theta plus radical 2 is equal to 0. Okay, now 0 product property. So cosine theta is equal to 0, and negative 2 sine theta plus radical 2 is equal to 0. Now let me continue to solve the right-hand side here. Subtracting radical 2 from both sides gives me negative 2 sine theta is equal to negative radical 2. Dividing both sides by negative 2 gives me sine theta is equal to radical 2 over 2. Notice a negative divided by a negative is a positive. So, where is cosine equal to 0? And again, picturing our quadrantal angles, cosine is x value. And take a look at these two angles. The coordinates here are 0, 1 and 0, -1. So notice how the x values are 0. That's why pi over 2 and 3 pi over 2 will be solutions. Now, in addition to that, the sine of what angle is equal to radical 2 over 2? This is one of the facts you should have memorized. We are talking about pi over 4, sine of pi over 4. Now, that's the reference angle, but there is more than one answer. So if you consider a diagram of pi over 4s to help you visualize what's happening, okay, we've got these 4 angles that have a reference angle of pi over 4. The sine of any one of them will give me some kind of radical 2 over 2. However, sine is positive in these two quadrants and negative in these two quadrants because sine is a y value. We want positive radical 2 over 2. That's why these two angles will be the solutions. So we will have pi over 4, but we will also have 3 pi over 4. Okay, so this is the solution. All right, that was problem number 13.